Okay, so let's recall. That f of the quantity x plus h shifts the graph of f of x h units left for h being a positive number. That is, horizontal translation is counterintuitive. So similarly, f of x minus h, for h a positive number, shifts the graph of f of x h units, counterintuitive, to the right. So right for h being a positive number. Okay, so let's note one thing before we begin with this one. Let's note. We have to do something interesting here. So if I have f of a plus or minus h, ax plus or minus h, so a coefficient on x, in order to find the horizontal translation, what we want to do is we want to factor out the coefficient of x. So this will be a times the quantity x plus or minus h divided by a. So remember, when you factor out, you're dividing each term by what you factor out. So this implies that horizontal translation will be plus or minus h over a. Okay, so given that, it's probably easier to see by example. So let's go ahead. So for example, let's plot the graph. Of, let's do f of theta is equal to 2 cosine of, let's do 3 theta minus pi. Okay, so I'm going to rewrite the function. So f of theta is equal to 2 times cosine of the quantity, 3 theta minus pi. And what I'm going to do is I'm going to factor out the coefficient of theta, that is 3. So in parentheses, what remains is theta minus pi over 3. So now I can do my normal analysis. So the amplitude A is 2, the coefficient in front. The period P is still 2 pi divided by the coefficient of theta. So regardless of whether or not we factored it out, the coefficient of theta is still 3. But now we have a translation. And remember, horizontal translation is counterintuitive. So this is not left, it's actually right, pi over 3. Because horizontal translation is counterintuitive. So let's go ahead and plot this. So theta versus f of theta coordinate axes. Hopefully I have enough room here. I'll make my quadrants a bit smaller. Let's do 1, 2, 3, 4 with an extra 1 attached. 1, 2, 3, 4. My amplitude is 2. I know that 4 quadrants is 2 pi divided by the coefficient 3. So each of these quadrants, pi over 2, pi, and 3 pi over 2, will be divided by 3 respectively. So this corresponds to negative pi over 6, negative pi over 3, negative pi over 2, and negative 2 pi over 3. So notice that I'm going right pi over 3 units. So everything's going to go right 2 quadrants, because 2 quadrants corresponds to pi over 3. So if I were to plot cosine Normally, prior to the horizontal translation, he would start at amplitude 2, go down to 0 on either side, go to negative amplitude, back to 0 on either side. Remember, it's symmetric with respect to the y-axis. It's a mirror image. So prior to horizontal translation, the graph of 2 cosine of 3 theta would look like so. However, I'm going to take each of these points, there would have been a point here, and I'm going to shift it to the right 2 quadrants. So this leftmost point up here shifts to the right 2 quadrants. This point down here shifts to the right 2 quadrants, already there. This point down here shifts to the right 2 quadrants. This point up here, down here. So everything is shifting to the right 2 quadrants. So I can just follow it. And it appears as though what we get is a graph that looks like so. Which in effect is the same as negating cosine, because what we're doing is we're just reflecting it about the x-axis. No, not drawn very well, but I'm trying. And there we are. Okay, so that's the graph shifted to the right 2 quadrants, quote, quote, in parentheses, or sorry, quotations. So notice the domain and range have not changed here, because I have not shifted vertically at all. Okay, so let's go ahead and do another one of these. So for example, let's do a reciprocal function. So example, let's plot f of theta is equal to, let's do negative cosecant of 2 theta minus pi over 2. Okay, so of course we're going to consider g of theta being equal to negative sine of 2 theta minus pi over 2 for purposes of helping us graph. Then I'm going to factor out the lead coefficient of theta, so that's 2, open parentheses. This will become theta minus pi over 4. So my amplitude is 1. My period is going to be 2 pi divided by the coefficient of theta, which is 2. So that gives me a period of pi. Now, do you know what? Let's change this. I already used minus. Let's make this a plus for this example, only because I want it to be counterintuitive. So if I have a plus pi over 4 inside, then that's going to be left, because it's counterintuitive, pi over 4. But there's one more thing we have. We have this minus sign, and we know that that minus sign is an x-axis reflection. So let's see if we can handle all of this in one fell swoop. So theta versus f of theta, coordinate axes. Do I have enough room here? I hope so. Okay, so theta versus f of theta. Maybe I'll make this a smaller scale than usual. Let's do 1, 2, 3, 4, almost 5 tick marks. 1, 2, 3, 4 tick marks. 1, -1. Okay, so I know that 4 tick marks is 2 pi divided by 2 in this case. So each quadrant will be divided by the coefficient of theta, which for us is 2. So let's divide that in each instance. So this will correspond to negative pi over 4, negative pi over 2, negative 3 pi over 4, and finally negative pi. So notice I'm shifting everything left pi over 4 units. So that's one quadrant. So everything's actually moving left one quote quote quadrant here. So now sine is used to plot cosecant, right? So normally sine would start at 0 and go upwards, but because it's negative, I'm going to right away just go downwards in one fell swoop. So I'm already enacting the reflection. So this is negative sine of 2 theta. Now let's shift that left one quadrant. So each of these points now gets shifted left one quadrant. So what we get then is this graph. And if you're hearing frogs, I don't know where they're coming from. Okay, so the reason I did this first is because the vertical asymptotes, let's do those in orange, are shifted. So because my x-intercepts have been shifted. So the vertical asymptotes to the graph of cosecant have to wait until I've shifted left or right before we plot them. Okay, so now finally I can plot the graph of cosecant, negative cosecant of 2 theta plus pi over 2, because I will meet at the peaks and the troughs of the negative sine graph that has been shifted to the left by 1 tick mark, or pi over 4 units. And notice that this appears to look like the graph of secant, because in effect, what the graph of a negative sine shifted 1 quadrant is negative cosine. Okay, so this we do have. Let's consider the domain here. We know that the domain must exclude all values of theta for which there is a vertical asymptote. So that looks like at pi over 4. Plus the distance between vertical asymptotes is pi over 2. So any integer multiple of pi over 2. So that's pretty straightforward. The range, however, has changed. Or has it? What is the range? Well, it looks like it's from negative infinity to negative 1. And then it starts again at 1 and goes to the infinite. Oh, so it hasn't changed, because moving left or right actually doesn't change the range. It's when we move up or down that the range changes.